Over 2 billion people worldwide consume products from these factories every day. Yes, over 5 million tons of butter are consumed annually, appearing in most meals around the world. However, few know that hidden behind those golden, creamy slices of butter is a modern and technologically advanced production process begins at massive dairy farms, where cows are milked hundreds of liters daily, fed into state-of-the-art production lines where automated machinery devours the milk, using the brutal force of centrifugal force to break down the fat and transform the rich, creamy milk into smooth blocks of butter in an instant. So, how do they turn fresh milk into butter? Let's uncover the entire complex technological process right now.
As you know, butter is made from milk, but primarily cow's milk. Its main components are milk fat, water, and a small amount of protein. This combination gives butter its smooth texture, characteristic rich flavor, and high nutritional value. The butter production process begins on dairy farms, where thousands of cows are cared for under optimal conditions. They are not only fed a balanced diet and live in a suitable environment, but even the milking process is optimized to ensure yield and quality. Dairy cows only begin producing milk after their first calf, which usually happens when they are about 2 years old. After giving birth to a calf, a dairy cow can produce milk steadily every day, with an average yield of about 25 to 30 liters throughout a lactation cycle of 305 consecutive days. However, if the cow does not continue to become pregnant and give birth to calves, the milk production will gradually decrease and eventually stop. Therefore, to maintain stable productivity, dairy cows need to be bred and give birth to calves regularly throughout their milking life. Farmers also mix natural milk with the calves to maximize milk yield. To ensure dairy cows receive sufficient nutrition for milk production, farmers must provide them with feed regularly every day. The diet of dairy cows mainly consists of silage made from corn, fresh grass, and various other supplements. This combination provides ample fiber, protein, and essential minerals, helping the cows maintain good health and achieve high milk yields. To harvest this feed, farms utilize various modern agricultural machines capable of quickly harvesting corn, alfalfa, and other fodder crops with high efficiency. These machines significantly reduce the need for manual labor, while also ensuring the best possible feed quality, contributing to the health of the herd and stable milk production year-round. After harvesting, corn and other fodder crops are chopped and piled into large mounds in silage pits or sealed in specialized plastic bags to remove air. In this anaerobic environment, natural lactic acid bacteria ferment the sugars in the raw materials and convert them into lactic acid. This process helps preserve the feed for a long time without spoilage, while maintaining its nutritional value for the cattle. After about 4 weeks, the fermentation process is complete and the feed is ready for use. At this point, the automated feeding system will take over the efficient distribution of feed to the herd. The feed is thoroughly mixed with ingredients such as corn, silage, hay, and nutritional additives to form a homogeneous mixture. Once complete, the system will automatically deliver the feed to the troughs, making it easily accessible for dairy cows and ensuring each ration has a balanced nutritional composition. Once the cows have been fed, they will automatically move to the dedicated milking area. Here, the first step is to clean the udders with water and disinfectant solution before milking. This process can be done manually or fully automatically by modern robots, ensuring hygiene and milk quality from the very beginning of the process. Next, vacuum cups are attached to the cow's udder. They mimic the natural suckling force of a calf, making the milking process gentle and comfortable for the animal. A dairy cow is typically milked up to 15 liters at a time, and most farms milk 2 to 3 times a day. After milking is complete, the milk flows directly into storage tanks, which are maintained at a temperature below 4 °C to ensure quality and keep the milk fresh under optimal storage conditions. Immediately afterward, the factories will come to the farm to collect the milk and transport it right away to the butter production factory. As soon as the milk arrives at the processing plant, it is kept at a controlled temperature to preserve its quality before undergoing more rigorous inspections. Technicians collect samples and analyze them using specialized equipment to detect bacteria, antibiotic residues, and to measure the levels of fat, protein, and lactose. If any batch fails to meet the required quality standards, it is rejected or processed separately and is never allowed into the butter production process. After passing inspections and meeting all quality standards, the milk is pumped from tanker trucks into the factory via a specialized pipeline system. The entire transportation process takes place in a closed system, ensuring the milk is delivered to storage tanks while minimizing the risk of contamination from the external environment. Next, the milk is pumped into massive stainless steel tanks, creating a clean and sterile environment. These tanks help preserve milk quality and prevent contamination throughout the storage process. First, the milk undergoes pasteurization. Here, the milk is heated to about 75 degrees Celsius for a short time to kill harmful bacteria while retaining most of the important nutrients. Throughout this process, an automatic stirring system continuously operates to distribute heat evenly throughout the tank, preventing overheating or clumping and maintaining a smooth and uniform texture. This process is typically quick, taking only about 30 seconds. Next, the milk is continuously stirred in large tanks to prepare for the cream separation process, which separates the milk fat from the rest of the milk. Typically, fresh milk contains only about 3 to 4% fat, so to produce butter, this fat needs to be separated and concentrated. The cream separation process is carried out using a high-speed centrifuge. Under the action of centrifugal force, the lighter fat particles concentrate into a stream of cream, while the skimmed milk, which has a higher density, is separated. Inside the machine, rotating parts spin at speeds up to 10,000 revolutions per minute, ensuring a fast and uniform separation process. During this process, vigorous stirring can create small air bubbles in the milk. Therefore, the system automatically removes this air to ensure optimal quality of the resulting cream. The entire cream processing and separation process typically takes about 2 to 3 hours, including storage, mixing, and continuous operation of the production line. After separating the cream from the milk, the high-fat cream is transferred to a specialized device where it undergoes a whipping process to remove excess water and form butter. This device rotates at approximately 3,000 revolutions per minute, creating a strong centrifugal force that causes the fat particles in the cream to bind together, gradually forming solid blocks of butter. The butter formation process relies on differences in density. The heavier water is pushed towards the sides of the rotating drum, while the lighter butter concentrates in the center, ready for subsequent steps such as mixing and packaging. Simultaneously, the remaining liquid after separation from the cream, known as buttermilk, is removed through a separate drainage system. This process creates a butter block with a smooth yet firm texture, while minimizing the amount of remaining water, contributing to extended shelf life and improved product quality. The entire process typically takes about an hour, enough time for the butter to achieve the desired smoothness and texture. On average, about 2.7 liters of milk will yield 250 grams of butter. After the water removal process is complete, large blocks of butter are removed from the equipment. At this stage, the butter has a smooth, creamy texture, but is still firm enough to maintain its shape. At this stage, the butter has a natural pale yellow color and a slightly moist surface due to the small amount of buttermilk remaining. The blocks of butter have a uniform texture, no longer in a creamy liquid state, but not yet reaching the complete firmness of the final product. To the touch, the butter feels smooth, pliable, and elastic, making it suitable for the next stage: kneading. During this stage, the butter is thoroughly kneaded to improve its texture and increase uniformity. Next, the softened butter blocks are transferred to a molding press, where they are compressed and shaped into large, uniformly sized blocks. The press applies strong pressure to compress the butter into metal molds, eliminating any remaining air pockets and creating a firmer texture. Throughout this process, the butter is pressed from multiple directions to ensure a uniform texture and even density distribution throughout the entire block. The large blocks of butter are then sent to a cutting machine, where they are divided into smaller portions for easier processing. Next, the butter passes through a grinding system, which smooths the butter and removes any remaining air bubbles, creating a completely uniform texture. Once the butter reaches the desired smoothness, the machine reshapes it into standard-sized blocks in preparation for packaging. Finally, the butter blocks are fed into an automated packaging line. Here, each block is cut to standard sizes before being packaged. The automated cutting system ensures each butter bar has an accurate weight, typically between 200 and 500 grams, while maintaining a high production speed, capable of packaging up to 100 butter bars per minute. After packaging, the butter bars pass through an automated labeling system. Finally, the products are packed into cardboard boxes, ready to be stored in cold storage before being transported to stores and supermarkets. So, you've learned the entire butter production process from start to finish. Did you find it helpful? If so, please like and subscribe to Mido Explained. If you have any questions or need corrections, please comment below the video. Goodbye, and see you in the next videos.